Okay, so let's see what we got here. So I already did this first page, so we'll kind of skip through that. All right, but you can see one way to do a reflection, right? One way we can do reflections is by using patty paper, right? Where you trace the image or object that you want to reflect along with that line of reflection, okay? And then you can fold along the line of reflection there and then retrace it, okay, to get its image, all right? If you wanted to actually finish off this problem, all right? If you wanted to finish off this problem, once you've done your reflection and stuff, I did not do a very good job tracing, I feel like. Anyway, if you wanted to kind of finish it off, what you could do is take your pencil and draw on these points right here, the images, and they should transfer over. You can very, very barely see them, but there they are. I'll just lightly or roughly retrace those points right there. Okay. And that's how you can then transfer the image back onto it there for the reflection. Okay. So that's one way that we're going to be doing reflections today. Okay. So let's take a look here then at how we're going to reflect using graph paper. All right. So we already talked about the fact that we have these perpendicular lines that show up when we connect a point in its image, okay, perpendicular to that line of reflection. So we already know what perpendicular lines are and perpendicular bisectors are. I guess we can skip right to here, okay? So a reflection across line L, okay, so there's our line L. It maps a point P to its image, P prime. Okay, right? No surprises there when we do a transformation. The pre-image or original, that's P, and then its image is P prime there. All right. If P is not on line L, then line L is the perpendicular bisector of segment P prime. All right, so that's how we know we've reflected correctly if that line of reflection, okay, is perpendicular and bisects the segment joining P and its image. Okay, there's no other point we could draw that would, create a perpendicular bisector with that point P like that for the reflection line L. All right, if P is on line L, right, then P is P prime. So there's that question again that I asked, Marex and Katie there, right? That it doesn't move. Their point doesn't move. It's on a line of reflection. Okay. So let's take a look here at doing this on graph paper, right? So what it has us doing here is using drawing the image of triangle ABC after reflection across line L. So here's our ABC. You can see that they started for us here. They recommend here drawing a segment with an endpoint at vertex A so that the segment is perpendicular to line L and is bisected by line L. Label the other endpoint of the segment A prime. Okay? So how can I guarantee here that we're going to be perpendicular to line L? Right? If we're in the coordinate plane here, how are perpendicular lines related in the coordinate plane? What did we just talk about last unit? How are perpendicular lines related if they're in the coordinate plane? Yeah, right?
They have the opposite slope.
Opposite reciprocal slopes, right? Okay. So Ryan, can you look there and tell me what is the slope of line L?
1 up 1.
Positive 1, positive 1?
Oh no.
Charles or Jack, can you help out?
-1.
Christian there, he just dropped this. Yeah, so -1 over 1, right? -1 over 1 would be the slope. If you're going down 1, right 1, down 1, right 1, or up 1, left 1, up 1, left 1 there. Mm-hmm. Okay. So then the perpendicular slope to that would be what? Yeah, +1 over +1, right? So then AA prime has to have a slope. And let me do it over here. All right. So that tells us the slope of what all these little segments have to be, right? But then we also kind of have to figure out how far to go to, right? So if I look here, right, I have to apply the slope 1, 2 times to get to my line of reflection, and so then I'll go 1, 2 times more to get to A prime. Okay. Here for B, how many slopes do I have to count? I have to count 1 slope, right? From B to the line of reflection, it's up 1, right 1, just once, right? And so then to get B prime, we'll do the same thing. Up 1, right 1 again, and there's where B prime will be. Okay. Now some of you guys might be able to just look at this and say, Mr. Wade, why are we even counting here? It's like just duh. It's like 1 diagonal square here and then 1 diagonal square there. And that's fine. If you're comfortable with the counting and stuff, do it that way. Okay, that's great. All right. but that creates there, right, that little perpendicular, that makes line L the perpendicular bisector. We'll do the same thing with C as well. Let's count that slope. Up one, right one, up one, right one. Ooh, up like a half, right a half. So we're going to kind of like use half a block there. So up a half, right a half, and then up one, right one, up one, right one. So we'll just go right to there. Okay. So again, we want to be the same distance. C to the line of reflection, point C to the line of reflection has to be the same distance as its image to the line of reflection as well. Okay. And we can just then connect all those guys. Okay. So there's us using that perpendicular idea that we talked about right in the last unit. Alrighty. Other options that you have here. Well, this is a piece of paper, isn't it? So you could fold this thing. Right? You could fold the paper along this line, okay, and then you have to trace on the back. You're going to see where it would match up, but you can absolutely fold it. You could use patty paper here too. Yeah, you could have traced it. Trace line reflection, trace point ABC, fold it, or fold over, and then trace, the reflection points, and then just transfer onto the paper there. So lots of options. Lots of strategies there. Okay, let's try another one here. Letter B. Okay. Let's go to Nick. Nick, what for letter B there on page 75? If you don't mind, real quick. All right, letter B. What is the slope of our reflection line here?
1/2.
Yeah, 1/2. Up one, right 2. And so then our perpendicular slope will be what?
-2.
-2/1. All right, very good. All right, question? Sure, so we're talking about the slope of line L here. Right, so just how do you find the slope for any line? Pick 2 points, right? You can then just count if you want to. Like here's a, I don't want to do, here's a point on the line, there's a point on the line, right? So what's the rise over the run? Rise 1, run 2. 1/2. Yes? Okay. And so then you're okay with the perpendicular then. Once you have the original slope, you're okay with identifying perpendicular, just opposite reciprocal. You take it, flip it, and make it the opposite. Okay? All right. So now we're gonna use these to find our point A here. So to find point A, let's see. I'm going to go down to right 1. Okay, and now we're to the line of reflection. So we'll do another down to right 1, and then there's where A prime will be. Okay. B, same deal. Down to right 1, down to right 1. Now it's line of reflection. So to get from B to line of reflection, it took down to right 1. Oh, wait a minute. Down to right 1, yeah. Okay, so 2 applications of that slope there. So we'll do it again. Down to right 1, down to right 1. And there's B prime. And then Murex, where's C prime going to end up? Right there. That's right. Good. C prime doesn't move. Why doesn't it move, Murex? On the line of reflection. You got it. Exactly right. On that line of reflection. Okay. And then you can use a straight edge to. I put my straight edge somewhere now. I don't know where it is. Gone. Okay. So we'll just connect by hand. Oof, that is ugly. There we go. Okay. What do you think about number 3? How can we check that we drew the image of the triangles correctly? How can we know that we drew the image of A prime, B prime, C prime correctly? What kind of things might we want to be able to see in the image there? Megan, you have any ideas on that? How can we check to see that this image, we drew it correctly of that original triangle there? Okay, so like do the reflections like in what way? Like using the patty paper or something? Or okay, yep. So you could like trace triangle ABC with your patty paper, okay, flip it over, right, and see if it matches up with A prime, B prime, C prime. I mean, just like this, right? I could like, and again, I'll do it really roughly here, but trying to save my paper. So there's A, there's B, there's C, there's the line of reflection. Okay, so I'll just like, and maybe I'll even label it here. A, B, C. Okay, if I flip my paper over and line back up my line of reflection, you can see in my pencil right there, there's C. All right, there's A, which is in the same place as A prime, and there's B, which is in the same place as B prime. So yep, that's one way to do it. Anyone else have other ideas about how we could check that we drew the image correctly? Yeah.
They look symmetrical.
If they look symmetrical, okay, yeah, symmetry would be something you could look for too. Steve, did you have an idea?
You could do what you did with the line, this one, or like backwards.
Okay.
Like,
Which one were you referring to? Because which one were you referring to? Sorry.
like when you're using slope, like
Okay.
you can turn the slope, you can find, like,
Oh, I see what you're saying. You're saying like reflect this over line L and see if it matches back to the original. Okay, yeah, that's a good idea. Yep. You could do the reflection of this back to see if it goes to the ABC. Yep. That's legit. Okay. Okay. And again, how can we tell that A prime is perpendicular to line L? Well, I mean, we counted it that way, right? We know the slope here was 1/2, and the slope between here to here, that's the slope of down to right 1. It's the exact opposite reciprocal slope there. Okay. One other tool that you have at your disposal here, and I'll show you that here for number 5. Okay. One other tool that you have at your disposal is the mirror. And I just realized that I gave all of my mirrors away, and I don't have one to demonstrate with. So I'm going to borrow yours real quick, and I'll give it back to you. Okay. So how do you use this to do a reflection? Well, what you're going to do is you're going to take your mirror, and you'll notice that there is a top and a bottom to this. So this is like how it's oriented, right? There is a top and a bottom to it. All right. The bottom has this kind of like, wow, that is like almost impossible to see. Does that help? The bottom has this like beveled edge to it, right? Okay, whereas the top does not. All right, you're going to take that beveled edge part and you're going to put it on your line of reflection. Okay? Thusly. Okay. Line it up there. Now, since our shape is on this side, when you look through your mirror, you'll see its reflection in your mirror. Okay? But at the same time, you'll also be able to look through, because the mirror is like transparent, you can also see your pencil on the other side as well, and you can identify the points where it reflects to. Right? So you might have to turn your paper to, for example, if you're right-handed, I'd recommend turning your paper upside down. Okay, so like most of us in here, right? All right. If you're right-handed, I recommend turning your paper upside down so that the object you're reflecting is on the left, and then your mirror there is to the right of it. And then it might be more easy to see. Okay? And with your mirror lined up, you can see the reflection of triangle ABC in your mirror. And then just put your pencil back there behind it and put dots where you see A, B, and C reflecting to B. And hopefully they'll line up to some grid points. It's not always perfect, but you get the idea, and you'll be able to identify there. Okay? Just like that. So there's going to be A prime, B prime, and C prime. Okay. Anyone having trouble? Yeah, so what you're going to want to do is just you want to just be like, there you go, maybe like you want to see just a smidge of your reflection line, and then maybe, but you get the idea. That might help too, because you're right, it's a bit of a, you have to finesse it a little bit sometimes, but you got the right idea. Anyone else having troubles? All right, so if you want to then, or if you're ready, go ahead and try number 6, okay, using any method you want. If you want to use patty paper, use patty paper. If you want to count the slope, count the slope. If you want to use a mirror, use a mirror. Okay, but go ahead and try number 6 then. Number 6, and I will do the same. Please make sure you label those points and their images too. Yes.
Maybe I like 4 with no names on them.
There are 4 with no names on them.
Yeah, and then like 3 of them don't have like the one up.
At all, you're saying?
Yeah, they only have the. And
All
then
right, I think this is Charles, right? Charles, this is Charles right here. So we got Charles there. That's okay. Oh, well.
Is that a 3? There's no
Yes,
three.
yeah, no,
Okay.
you're right. Well, shoot. All right, hang on. We got, so, who's missing? Sorry. Ryan, you got a question?
Are you ever going to give us mirrors on the test?
Yeah, we can use mirrors on the test. The other cool thing about mirrors too is if you can see here, for example, I put that we have a quiz coming up on October 2nd. But if you want to look at the world through rose-colored glasses, you can look and it disappears when you look through it. The quiz goes away. So there you go. Look at the world through rose-colored glasses. Sorry, I didn't get you wrong.
So 5, is the points labeled wrong, or is it supposed to be like the...
Oh. Yeah, I mislabeled them. Thank you, John. So yes, pay close attention to which image is which, and then I'll figure it out there. I'll kind of narrow the other ones.
Okay.
All right. So yeah. All right. You guys getting to work okay? Anyone struggling? Okay, it was Jack's. That's whose it is. All right. I think I have one no name here. Let's see. Anyone want to claim this no name warm up? Oh, it's not you, Brooke. Is it you, Gabby? It's not you, though. Oh, okay, then yes, go ahead. Brooke, you have a question? Oh, right there. Anyone want to claim this no name warm up? Nate, you think it's you? Okay. Gotcha. Maggie, did you think it was you? Oh, you have a question? All right, sorry. Just trying to take care of things here. Okay. Take care of this. All right, let me get Brooke down there with you. Okay. All right, let's drop. Right, you can't. So these 2 points, right, they're going to reflect over on this side. This point, it'll reflect over to this side. So you'll have to kind of do it once. You have to do it for these 2 points, then you have to turn your paper around and do it for this point over here. And do 2 reflections. So you look through that side to see A and B, and you look through this side to find C. What should we do? Point C? I would say let's do, so if you're going to look at this side, I recommend turning it so the beveled edge is on that side you're looking through. And then, line it up. Something like that. You look through there, look through this side, and then you get by your point C. And then you do the other side, turn your mirror around and do the other side.
So how would you sort of this
With the counting or the mirror? Which one are you talking about? With the counting. Okay, so what's the slope of the line of reflection? 3 over 1, right? 3. What's the perpendicular slope to that? Negative 1/3. So for B, for example, okay, down 1, right 3. There's your line of reflection. So down 1, right 3. There's your next one. Okay. For C, you're going to go the opposite. Instead of going down 1, right 3, because that's not a way. You want to go up 1, left 3, but that's still a negative 1/3 slope. Okay, sorry. I am coming, and then we'll move on here, folks. Thank you for your patience. You did? Yeah, you did. Looks good. Yep. You just have to look through both sides of the mirror, basically. Okay, for this one. All right. So there's our final image. Should look something like that. Should have done it in red pen there, so it stands out better. But there you go. Okie dokie. All righty. So of course there are. If you turn the page then to page 76, all right, we have coordinate notation. All right, so just like for translations, right, we were taking x, y, and then adding something to x or y to make it translate, right? We have reflections here for the coordinate plane. Okay. You can memorize these if you want to. All right, it might be helpful if that's like your bag. You like memorizing things and you want to do that. That's cool. All right. The x-axis and y-axis ones, those are pretty easy to do just to have them done. They should hopefully make sense, right? I mean, for example, here you can see, all right, a reflection across the y-axis, right? Well, if that's the case, it's just going to be like a horizontal, kind of like reflection there, right? The M point does not go up or down at all. It just changes its positive x-coordinate to a negative x-coordinate, right? And then here N, right, its positive x-coordinate will change to a negative x-coordinate. And then P, its x-coordinate, right, of 3 changes to a negative, or the opposite, negative 3, right? But the y-coordinates all stay the same. They stay the same height, right? We're just moving the points across there, okay? So that's all those are, right? And the same thing would be if we were reflecting across the x-axis, it would be the y-coordinate that is opposite, and the x-coordinate stays the same, okay? Reflecting across the line y equals x, now that changes it up a little bit, right? xy becomes yx, so you flip your x and y coordinates, right? And in fact, we have an example of that down here in letter B, okay? So go ahead, why don't you guys fill out the chart there, and then, let's see, there's 1, 2, yeah. So why don't you guys fill out the chart, graph the 3 image, the original, and then graph these image points if you like, okay? Let's go ahead and try this one too, all right? So I'll give that right there to help you, right? So xy becomes yx. No. Yes. Rex just asked a question, and I'll let everyone know, just so you guys know, these are not on your formula sheet, so guess what? You don't get them, okay? So, again, you can kind of, like, do you need to memorize them? Not necessarily, no. I mean, you know how to graph the line y equals x, right? And we just did reflections, okay, in the coordinate plane, all right, without using any sort of coordinate rules like this, okay? But you should be able to come up with these for sure, okay? So if that means you memorize them, or if that means you just figure them out in the middle of the assessment or on your own kind of thing, that's fine, okay? And I can, talk you through that if you want some help with that too, all right? So anyway, but yes, you won't be given those, so. All right, here's what your B should look like, right? There's your part B. So since we're reflecting over the line y equals x, that means xy becomes yx. Okay. And so there are all our points. All right. There are all the points right there. Caden, why didn't E change? It's the same number. Mm-hmm. That's right. And because we're doing a reflection here, if a point and its image doesn't change, we also know that point is where? On the line of reflection, right? Which is true, right? Because the line of reflection is the line y equals x, which means you have a y-intercept of 0, a slope of 1 over 1. And so our line of reflection is going to look like this. Ooh, there you go, like that. And so you can see, E is on the line of reflection there. So that's why it doesn't move. If you drew in the line of reflection, again, if you drew in the line y equals x, then you could have counted the slopes if you wanted to. Okay, you could have counted. E stays the same, D goes in. All right, so something to think about there. Or you could have used a mirror too, right? You got the mirrors, right? Those are available to you. All right. Okay, so why don't you guys go ahead and try on page 77 there, 9 and 10. Okay, try 9 and 10 there. You have this one, you're reflecting across the x-axis. This one, you're reflecting across the line y equals negative x. If you want to draw in your lines of reflection to help you, feel free. Okay, if you want to use the mirror, do it. If you want to use pie paper, do it. If you want to count, do it. Okay, you have 3 different options at least, right? So do whatever you want there. And I will do these as well. Bob. So let's see what timer's going off here. Okay. If you finish that, feel free to go ahead and take a look at numbers 12 and 13 on page 78. Okay, so you finish that. Take a look at page number 13, 12 and 13 on page 78. Okay, and think about how you might do those. Now, granted, there's like examples in the in-between, so you can like look at those if you want to for some help about how to figure that out. Okay. Take a look at page 78, number 12 and 13. Oh, question two, sorry. Think about how you might find those lines of reflection on 12 and 13. Okay. Okay, what about it? Like how you know that's a line of reflection? Like how I came up with this. 0. So you go through the, all y's with the 0, and you're told it's negative 1 over 1. So down 1, right 1, down 1, right 1, down 1, create that line. Okay? So then are you then, so that's how you put the line, and then you want to reflect it. Is that great? Perpendicular slope. You can count it like that. Yep. All right, so question. Yes, right with you. 1 second. Man. This is your line of reflection right here, right? For y equals negative x. And again, the reason why we know that is because think about slope-intercept form, right? The b is 0, the slope is negative 1, right? So down 1, right 1, down 1, right 1. That's how you can create that line right there. Okay? So, or you could use this coordinate notation too if you wanted to. Yeah. All right. Oh, but remember they flip too. X, y becomes negative y, negative x. CC also switches positions too. So that's why those kind of flipped around like that. Okay. Bless you. Okay. Bless you again. All right, sorry. This is what you can see right there, the answer is. So let's talk about that 12 and 13 then. Okay, if you've had a chance now to think about this for a little bit. Okay. What's one way we can come up with the line of reflection for this particular place? Go ahead, please. Okay, so yeah, find the midpoint of the segment that connects like B prime, A prime, C prime. And you can do that a couple different ways, right? You can count it if you want to, right? So we know here, this is like 2 diagonal boxes, so we can just say, okay, well, 1 diagonal box will be right there, kind of thing. And then once I find, well, here, C prime also has 2 diagonal boxes, so in the midpoint there. And then once you have those 2 points, boom, you can create your line of reflection, right? So there's like the midpoint between C and C prime. There's the midpoint between B and B prime. There's our line of reflection. Rex, did you have a different idea?
I can use the mirror.
Use the mirror. Okay, how would you use the mirror to do it?
Just set it up until it lines up and then mark the spot.
Yeah, I mean, so again, you guys kind of have to eyeball it a little bit, but right, you just stick the mirror kind of right in between there. All right, and then you just adjust your mirror until, you know, one reflects onto the other. Okay? Once we've done that, then, Marex, now what do we do? I mean, I've lined it up, now what?
You just mark where it is.
Yeah, just mark the line along the beveled edge there, exactly right. Like that, okay? So you can also use a mirror in that sense, too. Okay? How else can we find the line of reflection? Anyone come up with another idea? So again, we could find the midpoint between a point and its image. Okay? We can use the mirror. What else can we use here to find the line of reflection? Yeah?
You could find the perpendicular line.
Okay, yeah, perpendicular line, and then we would also need to make sure it's in the middle as well. How could we do that? Because the perpendicular line to this would be, I mean, we have the perpendicular slope, but we need to find the perpendicular bisector, right? So how can we find that? Or what would you say there to that? Or you want to think about that a little more maybe? What do we think? How can we find a perpendicular bisector? Right? If I connect B and D prime, right? Can't we find the perpendicular bisector of a segment? Use a compass, right? You can also use a compass. Swipe, right? Football construction there, and then it'll go right through. Okay? So you can also use a compass and straight edge. And then finally, how can we use patty paper to find our line of reflection here? Yeah, page. Yeah, trace them both, fold the paper in half so that you match these two shapes up, and then where will the line of reflection be? Where the fold line is, yeah, the creases, exactly right. Okay, so you have a lot of options here. All right, we already did this one here, so we just kind of finish that one off. Ooh. Not drawing lines very well there. Okay. In this one in 13, okay, there are some points that don't move, right? Right here and right here. It looks like they kind of stay the same. But you can also use your patty paper or your mirror there to help you as well. Okay, your choice. Or you can find those midpoints. So let's see if I go down to right one, down to, yeah, there you go. So that's the midpoint right there. And then for C, it's down to right one, down to right one there. So there's C right there. And you can connect the dots that way. Yeah, I'm not sure where I put my straight edge, so I'll just use my pad of sticky notes there. Okay. One last thing here I want to talk about. Mini golf. Okay. I don't know about you. I am not much of a golfer, but I love miniature golf. Okay. I love miniature golf. So, how can we strategize using reflections? All right. How can we strategize using reflections? Well, there are sometimes situations, right, in a miniature golf course where the tee, right, there is not a direct line of sight to the hole, right? Right now, if you were to try and, hit the ball here at point T, which is where the tee would be, if you're trying to hit it, right, you can see that from the tee to the hole, you would hit the wall right here. Okay. But what you can do is bank your shot, right? You can purposely bounce, your shot here from T so they go into H. All right. How can you know where you're supposed to hit it? Well, if we are going to use this wall BC here, we can just reflect point H over that wall. Okay, so like the wall we're going to bank it off of, right? Reflect it over. And then if you connect T to H prime, okay, you will see the precise place on the wall where you should hit it. Of course, understand that it's hopefully a flat, it's flat all around there or something like that, and not, I don't know, you get anything. But you'll see the precise place on the wall where you should hit it to then have it bank in, okay? Because the angle at which a ball hits a wall will be the same as the angle at which it leaves, right? If you remember that, there was a question on the test from Unit 1, okay? So these two angles right there will be the same. And hopefully then you get a nice hole-in-one. You can laugh in your friends' or family's faces. Right. So there's an application of geometry right there. Feel free to use that on your next miniature golf topic. Okay. Questions on any of that? All right. So then, for your assignment, well, I believe it is in Schoology, but just in case it isn't, I'll put it up here on the board. I'm pretty sure I put it on Schoology. So the homework's going to be this. Page. Oh boy, I'm losing my place here. Okay. Starts on page 81. And I'm going to have you numbers. Let's see, I think I had you do numbers 1 through 15, the odds. And then I think I also have you doing. Bless you. Bless you. I think I have you doing 18 through 24, but you're going to skip. And now I want to make sure I'm doing this one right because I don't want to give you the wrong.